The following is an AZPM original production.
Arizona Science is supported by Research Corporation for Science Advancement.
For Arizona Public Media, I'm Tim Swindle, Professor Emeritus of Planetary Science at the University of Arizona, and this is Arizona Science. Joining me today is Daijun Li, an Assistant Professor of Ecology and Evolutionary Biology at the university. Welcome, Daijun.
Thanks for having me.
Daijun, you recently led a study of how certain plants and their pollinators respond to extreme weather events. We know that there's sort of a dance of plants and animals so that crucial activities happen at the right time, but what happens when an extreme weather event happens?
Yeah, that's a great question. That's exactly what we were interested in. So if we think about individual plants or pollinators, and I think, we kind of, or they respond to the immediate environmental cue, right? More than the gradual climate change or environmental change in that sense. And but so far, most of the study focus on how the gradual environmental change affect the responses of individual plants or pollinators. And we don't really know much about how they respond to immediate environmental cues such as extreme weather events.
If you have an extreme weather event one year and things respond to it, but then the weather goes back to normal the next, will they go back to their normal cycle, or does it reset after a certain length of time, or how does that work?
So far, we don't really have this kind of a temporal data to look at that. And so far, we use the iNaturalist data, which is a citizen science program. And we most look at spatial patterns because we the lack of the temporal data.
What's the actual data that you are taking out of iNaturalist?
iNaturalist is a citizen science program that everyone can take a picture of any living thing and post it online. And we look at those images and we look at the phenology, which is the timing of key life history events such as the flowering for plants. And for pollinators, we just look at when they came out and fly and pollinate. And the information we get is like, when we saw a picture from iNaturalist, we look at it, does it have flower? And then the records will have the time, the date, and the location. So that's basically the information we get.
How many years' worth of data were you looking at typically?
iNaturalist really took off in the past 10 years so we focus in the past 10 years and take the average kind of, response over this 10 years window.
And then you have to combine that with, for instance, weather reports and that sort of thing?
Yeah, so we use like a daily weather. So because we need to configure whether a day is a extreme day in some sense, right? Whether it's like the temperature or the precipitations.
When you say an extreme event, are you talking about a day that's unusual or a week that's unusual or a season or which?
Here we look at a daily temperature or daily precipitation, and we look at 7 days window and take the average of that 7 days of window with a particular focus day in the middle of that 7 days, and we compare with historical periods such as 1980s to 2010, and then we just compare with that benchmark and say whether a specific day has extreme weather or not.
What is the overall project that you're trying to accomplish here?
Here, the study we talked here was a smaller part of a larger project that we aim to build a global database of plant phenology. So we were trying to integrate existing observatory data, such as those by the U.S. National Phenology Network, which actually has its center here at the University of Arizona. And we were trying to integrate this data, but also try to extract phenological information from existing images from iNaturalist, as well as digitize the specimen. So in the hope of building this global central database of plant phenology to facilitate phenological research.
Thanks for talking with us.
Yeah, my pleasure.
Our guest today has been Daijun Li, who studies the timing of how plants and animals respond to seasonal changes and how extreme events can affect that. This is Tim Swindle, and you have been listening to Arizona Science. You can also listen to this and other Arizona Science segments by going to the AZPM website at azpm.org.
Thank you to Research Corporation for Science Advancement for their support of Arizona Science. AZPM podcasts are made possible in part by donations from listeners like you. Learn more at support.azpm.org. Thank you.